Dear students, welcome to the 7th session of Mobile and Pervasive Computing, CS710. Today we will continue talking about the software development aspect of mobile and pervasive computing, and we will see how we term as the development of the pervasive computing software as difficult. Before moving on to discuss those aspects, let me first go through what we discussed last time. We talked that while defining mobile and pervasive computing, there are two key aspects that we should take into consideration. One is the aspect or the dimension of mobility, and second is the dimension of context awareness. We talked that mobility has its own implication while we develop the software, and the context awareness parts has its own set of problems that it brings on to the software development cycle of mobile or pervasive computing. Mobility, as we discussed before, is of two kinds. The first kind of mobility is that of user mobility, that a person moves from one place to another. While doing so, the obvious implication is that of network connection. We already discussed that the smartness of the pervasive space vary. In some cases, you might get an excellent connection. In some cases, there might be a dead spot. So the network connectivity vary. And the pervasive software that we are going to develop needs to take care of that aspect. The second mobility is that of the device mobility. That means that the application should be able to run from one device or to other. It should behave the same way. That is, the application should be portable when moved from one device to another. That is application portability or device portability. While doing so, we have to devise a software that is capable of running on all kind of devices that are available. Just like what we do with the desktop software, that when we develop a software for one computer or one operating system, if we want it to run universally, we develop a ported versions of it. If we want our software to run on Windows and on Linux, then we will be probably making two different kind of versions of it, because the underlying mechanism of Windows and Linux are different. Then the third thing that mobility brings into account is if the application is context aware, that is, it is gathering information from its different sources, then it should also realize the fact that when a user moves from one place to another, the context changes. Or when the application is moved from one device to another, its context changes. If you remember, we defined context as the objective we are trying to achieve, the person who are using it, and the environment it is being used in. So with mobility, this is the third implication or third problem that brings on board, that the context of the device or the application can change any time without prior notice, and the software that is running on that platform needs to take care of it. Then we moved on and we talked about what are the implications of context awareness. Context, as I just said, is your environment, the device you are operating on, the person who is operating the device, and the objective we are trying to achieve. The context awareness or context aware devices or context aware application brings their own set of the problems on board. One of them is that how would you collect this information or this data from your surroundings? How would you detect, let's say for example, the location of the user? Where is the user currently standing? Or how would you detect that what he is trying to achieve? Or how would you detect that what is the weather at that place? For location, maybe some of the applications would rely on GPS. Now, GPS coordinates can be achieved or can be retrieved through multiple sources. You can have a direct satellite connection, or it can be network assisted like the one GPRS offers you. Then once you have the data, how would you analyze this data? How would you make it fit for usage? That is another dimension. And then how would you use this data to pass on to other devices or other applications that would probably need it? That is the third implication of context awareness. We term as inter and intra application usage. That is how the data will be used within the application itself and how the data or the information will be used among different applications that may come together to achieve a common function. So that is the third implication of mobile context aware application. We moved on and we said that developing software for pervasive platform is difficult. First of all, we said it's different, and that is for obvious reason that now we are developing for devices that are inherently different from those that we see in the desktop world. But it is difficult too. And why is this difficult? Because now the portability aspect of the devices is very big. Where in desktop environment, we are only concentrating on few operating system. I dare say few because last time when we counted, they come close to most probably 50 or 60 of them, counting all version of Linux, counting all flavors of Windows, counting Mac OS, counting some of the new and upcoming operating systems like Android and Chrome. Altogether, their count was about 50 or 60, where Nokia alone has 113 or 120 devices alone in Asia region. So you can see the magnitude of the problem when you think of porting your application from one device to another. We also discussed few definitions that will help us while we are understanding the architecture or the software model of the pervasive computing. We said that multi-device applications are those that are able to run on multi-devices. By multiple devices, we mean that they will be able to run on different operating systems. By multiple devices, we mean that they are able to run on different models by the same vendor using the same operating systems. By multi-device, we mean that they will be able to run on different screen resolutions and all those things. We also said that multi-model applications are those who are able to get input from variety of sources. That can be simple user interaction through UI, user interface, or can be speech recognition, or can be gesture recognition. All of them are a valid input to any application, and a multi-model application would be the one who would be able to recognize a number of them. To put it formally, the multi-model application would be able to recognize 2 or more input methods. Then we discussed the prevalent architecture that we use in mobile software development. That architecture that we develop, or that software methodology that we directly borrowed from the desktop environment, is called model view controller. we said that any application can be divided into three parts. The first one is the architecture, that is how the application would be built, how the data stores will be placed, how the data will be stored, and all those things, the logic behind the whole application. Then the second part was the flow, that is how the application will change states, how the application will go from one state to another, what are the input required to make this transition, or what are the processing that will be required to make this transition. This is also represented as state diagrams or flow charts. The third component was the user interface or the view, how the application will be presented to user. In software terminology or software engineering terminology, we dub these three things as model, view, controller architecture, where model is your logic, your data stores, how they are stored. Controller controls the flow of your program, and then view is how the application is presented to the end user. We also said that model is the core. This is what relates. If we relate those three concepts and these three concepts, then model relates to architecture, the controller relates to the flow, and the presentation relates to the view. The user experience or user interaction is defined by view and controller together. Then we moved on and we said, okay, we are talking about networked applications. We said this is the most common ones. This is the ones that represents the most common or most exciting area of pervasive computing, because now we are talking about the smart environment. That is, we have connectivity. It's filled with connectivity. It's filled with processing elements, and we have to make use of it. So this is a very exciting area. So in this, when we talk about software engineering aspect, we will be talking about mostly the networked applications. And we said when we talked about networks, then there would be two or more computing elements involved, and definitely there will be connectivity, and we termed it as distributed platform or distributed software platform. The question here was that how would we decide which component will be doing what? And I said that this is something that you decide while building the application. In other words, this varies from application to application. In some application, you would decide differently than the requirement, or the requirement of the other application may dictate something different. This is quite normal. But what we know is that we can categorize these applications according to some very loose definitions. And this is again where the desktop computing environment came to our help. And we said that, okay, there is a concept that called thick and thin client. And we can borrow the same here too. The thin client applications are those that runs minimally on the client. That is, the minimum component of any application would be running on the client itself. Usually this is the user interaction part or the presentation part that is rendered on the device itself. Other components are running on a network server, on a network machine somewhere else, and you will get the information as and when needed. On the other end, the thick clients are those that are able or that run most of their components on the client, and they would need very less information from the network components. They still might have something running on the network, because we are saying here that we will discuss those applications that have network components. So we will have to see what kind of those devices that have thick client but still requires network connectivity for some accessing some components. We will come to that, but for now, thick clients are those who will run most of their operations on the client itself. So these were the few definitions that we come across. Continuing with today's lecture, we will continue to see what are these differences would mean. What would these different devices, model, or a huge number of platforms availability would mean to us. As I said last time, that portability is the key concept here. That is, when we have such a huge number of platforms available, it would be quite difficult to port our software from one place to another. Why is that? Think about this. For writing any software, we usually depend on certain APIs. हम कुछ APIs पे depend करते हैं. ये APIs वो होती हैं जो कि ऑपरेटिंग सिस्टम लिखने वाला हमें प्रोवाइड करता है. विंडोज़ की अगर मिसाल लें तो विंडोज़ में प्रेजेंटेशन के लिए या यूज़र इंटरफेसेस के लिए कुछ APIs हैं. आप उनको यूज़ करते हैं तो आपके लिए एक बटन बन जाता है. आप उनको यूज़ करते हुए अपने लिए विंडोज़ क्रिएट करते हैं. आप उनको यूज़ करते हुए कंटेंट प्लेस करते हैं. आपको नेटवर्क कनेक्टिविटी चाहिए, उसके लिए आपको डिफरेंट सेट ऑफ APIs अवेलेबल है. आप उनको यूज़ करते हुए अपने लिए नेटवर्क कनेक्शंस ओपन करते हैं, क्लोज करते हैं, डाटा सेंड करते हैं, डाटा रिसीव करते हैं. ये तमाम काम कम्युनिकेशन APIs के थ्रू होते हैं. आपने फाइल मैनेजमेंट करनी है, उसके लिए आपको एक डिफरेंट सेट ऑफ APIs मिल जाते हैं. आपने डेटाबेस कनेक्टिविटी लेनी है तो आप ODBC या JDBC ड्राइवर्स यूज़ करते हैं जो कि इन टर्न अगेन आपको कुछ APIs देते हैं. सिमिलरली मोबाइल इन्वायरमेंट में भी ऑपरेटिंग सिस्टम्स जो होते हैं, दे विल प्रोवाइड यू विद सर्टेन APIs. But these APIs would vary from one place to another or one platform to another. ये तो सिंपल हो गया the correlation between operating systems कि जी ऑपरेटिंग सिस्टम वहाँ पे भी होते हैं, वो भी आपको APIs दे देते हैं. यहाँ पे भी ऑपरेटिंग सिस्टम्स होते हैं, वो भी आपको APIs दे देते हैं. In addition, what is different is that mobile platform is multi-model. That is, in variety of mobile platforms that are available, you have so many input options available that are not available on traditional desktop systems. You have touch, you have voice recognition, you have keyboards, you have trackball, where in traditional desktop software, we are only talking about keyboard and mouse, and that's all about it. So these are the differences when it comes to input. Then what we learned in desktop environment, that we are able to use the processors in multiple ways, we are able to use the devices or hardware available in multiple ways, that is also restricted here. Whatever we learned in traditional Intel platform may be of little use when we come on mobile platform. Why? Because now we are talking about a totally different breed of network processors. We are probably talking about, we don't have MMX anymore. So if our application was taking advantage of MMX or multimedia extensions, maybe our mobile processor wouldn't be able to afford it. Because let's face it, we are running on mobile power or limited power, and we are not able to carry on this heavy operations. Then if there we are talking about Intel, here we are on ARM processor, a totally different instruction set. We will have it to learn, we will have to learn it all together. Where in desktop environment we are content with a LAN card and a Wi-Fi access. In mobile devices, we don't have LAN card altogether. So we are only limited with Wi-Fi. But in addition, we are tempted with another wireless medium that is called GPRS. Limited, but yes, it is another medium that can help us connect. Problem here is that when you take out LAN, our network connectivity becomes a question mark, because wired medium is much more reliable than that of wireless medium, be it Wi-Fi, be it WiMAX, or the traditional GPRS. All of them are wireless medium and they are not so much reliable. Then there is some additional functional hardware that are available on the mobile platform. For example, in some cases we have GPS functionality that we can use mobile to fetch our GPS location. This is something that is not available on the desktop platform. So all these things come together and make the Pervasive platform or the mobile platform much more challenging than it is. We will term this phenomena as heterogeneity of mobile platforms, that mobile platforms are different. Now let's see what is the effect of this heterogeneity on the mobile platform. Now let's see what would be the impact of heterogeneity of mobile platforms on our software development. Let's first consider the case of user interface. User interface is described by how you would give input to the device and how you will see the output from the device. That is the presentation of your application. Devices, as we discussed earlier, differ in this regard. Some of the devices nowadays comes handy and fully equipped with a small keyboard that you can use. Other devices lets you use an on-screen keyboard with touch capability. Yet other devices only have the numeric pad, and at the numeric pad you have the text too, so you will press them a number of times to get your desired character. In some platforms you will get voice recognition. In other platforms you may have the orientation detection, that whether in which way the device is pointing. It's upside down, it's turned left, it's turned right. This functionality is called accelerometer. Some of the modern devices come equipped with accelerometer, such as the modern Android phones and the iPhone phone. These are the devices, these are some example of devices that have accelerometer built in. Then yet again the problem is of the SDKs or software development kits. When developing software, we don't write everything from scratch. This is a very old concept that the software components should be reusable, and APIs were just a product of that thinking, that most of they write the framework for you, and you build your application on the top of it. The SDKs or the APIs are different for different platforms. This is mainly because every platform has a different way of showing things. Every platform has a different way of accepting input from the user. And on the top of it, some device platforms support some functionality and others don't. So their APIs or their SDKs are made according to that. So view component or presentation component has to be heavily rewritten when we go from one platform to another, or when we decide to port our application from one platform to another. Then comes the other effect of the heterogeneity of devices, and this other effect is that of user interaction. If you remember, I said in one of my previous lectures that user interaction is defined by view and the controller component of the model view architecture. View, we already saw that it has to be rewritten heavily if we want to port our device from or our application from one device to another. There are other things that needs to be taken care of in context of the controller of the application. How your application will control the execution. Controller is the part which decides how your program will move from one state to another. Say for example, if in one case we are heavily dependent on GPS, that is, when our location changes, our program states changes too. In that case, in one device it might well work very fine, but in other cases where the GPS is missing, we'll have to think of something else. Or to make things a little bit more simpler, let's say both of the devices are equipped with GPS, but in one case we are outside and we are able to get the GPS coordinates easily, but in the other case we are inside a closed environment, like in a room where GPS are not easily available from the satellite itself. Then how would we get this information in order to change the state? So this is few things that when it comes to the controller of an application we will have to consider. Then comes the platform capabilities. Now our platform is distributed platform. That is, we have decided to keep some of the components on the network service and some of them would be running on our client. What and when would be running on server machines, and what and when would be running on the client itself? This is the question. This is where we bifurcate the components. This is where we decide that what functionality goes when, and this is the part of our architecture. In some cases we might go for thick client, and in some cases we might decide for thin client. In what scenario we decide what, that is totally application dependent. That is not something that we make a general rule out of it, that this goes here and this goes here. It's totally application dependent, and it's totally the device on which it would be running dependent. In some cases we might want that everything should run on the device itself, but device itself is not capable of running all those things. In other cases the device is very capable, but the elements or the components that we need for the proper execution are better placed on a server itself. Example of it, Google Maps. We can't afford to put all the maps in our device itself. Why? Because we are limited by weight and mobility aspect, if you remember. That also affects how much memory we get. So therefore, what we decide is that, okay, our maps will be residing on a server in Google vicinity somewhere, and what we will do is that we will only get the GPS coordinates and we'll pass on to that Google Maps. The Google Maps will plot it for us, and then we will get a plotted screen back and we will show it to the user. So how would we distribute the functionality amongst different components? That is, we will term as platform capability, and that is another aspect of what device heterogeneity or platform heterogeneity plays a very significant role in. Uske baad we will see the most important aspect. This is the one that will keep us bothering from time to time, and that is the very key line that we talked about, that is smartness of spaces vary, or smartness of pervasive spaces vary. This has a very sound effect on one thing, that is your connectivity, the applications connectivity. Now we are talking about network applications, and we are also saying that our connectivity is not reliable. How would we do that? How would we let our application run in such a way that user won't notice, that we present minimum surprises for the user? Because if we continue to give user surprises saying, okay, you don't have connectivity, okay, you can not work on this application anymore, or I wouldn't perform very well because you don't have network conditions, or in any way if we let user into the technical details of application, we have come from the invisible mode to visible mode, and we have defined the basic definition of pervasive computing, that it should be invisible. That is, most of the time it should work according to the user requirement and present him with little or no surprises. In this context, a very important concept is disconnected operation. That is, okay, well, we understand that connectivity is beyond our reach. Even these multi-million-dollar companies that are setting up the cellular network in the country, they even at some places can't provide connectivity. So we have very limited resources, and if the GPRS is our last resort, because this is the comprehensive connectivity through GPRS. But in some cases, when we don't have even GPRS, what will we do? And the solution is disconnected operation. That is, the application should be built in a way that it should accommodate the fact that in some cases there would be limited or no connectivity. And it should have this provision that what will happen then. This is a similar concept that we use in distributed in the desktop computing, is that okay, the user is expecting, or the application is expecting the user to enter A, B, and C. But what if user press 1, 2, and 3? What will happen then? This is termed as robustness of the application. That what happens when the application gets unexpected input, or in mobile domain or the pervasive domain, what happens when our connectivity is unexpected? How our application will perform in downgraded network conditions. Downgraded network conditions mean that from Wi-Fi that is 54 Mbps, we are at 144 kbps, that is GPRS. A huge difference. How would we perform then? Or even worse, how would we perform when there is no connectivity at all? This is defined under the term disconnected operations. How will we take care of the connectivity problems? Connectivity also becomes important that now, because we are not only fetching some information from other place. It's not that there is a DB somewhere and we go and fetch some data and we changed it and now we can't put it there. That is just a problem of data consistency that we discussed earlier. Now the problem magnitude is a little bit more. And the problem is that now our own applications components are scattered on the network. For example, if we have a route planning application that takes the GPS of our current location and our destination and map the route using the Google Maps, if we don't have any connectivity, we would not be able to do it. So simply our application would fail at that point. Other scenario may be that now we have a very limited connectivity, that is, we are connected through GPRS and our data connection is very slow. What would we do then? How would we decide that our application should behave in that environment? In this regard, we should also consider that how would our application components will synchronize with each other. Remember, now we have, think of model view controller, we may have different components, view sitting at some place, model sitting at different place, controller sitting at different place, depending on what your application logic is. In some cases, your client may be running view and controller, and model may be sitting someplace. That is all your application logic or how you decided to build your application. But in any case, if your model is sitting at some server and your user interaction is at your client, you would still need to know what to do or where to store your data, or where to retrieve your data from, or what logic to apply on that data. It's all stored on the server, and once you lose that connectivity, your application might not move ahead. One of the techniques that we use in this is caching, that most frequent things or most frequent data is stored on the client itself, so that even if you lose your connectivity, you still be able to continue processing for some time. Or in some cases, you pre-decide that whenever you get connectivity, it's not, you are looking for an opportunity that whenever you connect, this is the things that are needed from the servers immediately. For example, if you can't find your GPS location because you are indoor, your GPS device, you might want to program your GPS device in such a way that it will continue trying until it gets the GPS location, and then it will continue. So to user, our goal is to present minimum surprises to the user, and that's where we come, that's how we see pervasive platform being evolved. This is the heterogeneity of devices, platform, the applications itself, connectivity, how would we distribute them. This all comes under how the heterogeneous platforms or how the heterogeneity of pervasive platforms affect our capability to develop software for it. The other aspect, the context awareness, and we get the same set of problems there too. The first one is that context-aware applications must get data from multiple sources. Now, multiple sources mean that you are talking about multiple formats. If you remember our use case one, and let me just briefly describe it. Our user is in an airport terminal, carrying a mobile device, and he needs to do some urgent communication before his flight comes, and he boards the plane, because once on the plane, he has to turn on his device, and the communication is urgent, and that needs to go out right away. Now, he is trying to send this urgent communication, but the network is congested. Why is that? Because many people are at that terminal, all waiting for the same flight, and everybody in their free time is trying to access internet. Some are watching videos on YouTube, some are doing their office work, some are doing some heavy browsing. All those things has made the network very congested. The user is finding it very difficult to send all the communication. So in that case, what our pervasive application did was that it consulted the network monitor, that is NMS maybe, that is installed in the airport, and it consulted the flight services, and it consulted the weather services, and then it come to the conclusion that okay, there is a very nearby gate at like 5 minutes walk that is not congested because there is no flight scheduled at that gate, and the network conditions are much better there. So if the user goes to that gate, he will be able to finish his communication before the flight arrival, and he suggests the user to go to that gate, and he complies. In this use case, we have gathered data from multiple sources. We have talked to flight services, we have talked to weather services, we have talked to NMS. All these are different sources of data. Some of them may be providing you information in XML format. Some of them would be just giving you, let's say, binary output. that you query them, is flight scheduled for gate 15, and they will say yes or no, either 0 or 1. In some cases, you will get a simple number or series of number. In some cases, you might just get a simple data stream. So this is variety of data formats that are available, and the pervasive application should be able to get and understand this variety of information that is being fed to it. Second is that these context sources from wherever our information is coming, they are also very different. The way the satellite is providing me with my current location might be very different than the way my Wi-Fi is providing me with my current location. This is, and let me just make up an example here, that when I query a satellite, it will give me directly longitude and latitude, that this is your longitude and this is your latitude, and if you put it on the map, you will get this information that where your currently is, I mean, with reference to buildings and all those. But when I query the Wi-Fi, Wi-Fi would have been, might be programmed differently, and it will give me my location as this, that in my coverage area, you are at this point. And how he detects it? The Wi-Fi device detects it through the signal strength, that it will probe your network adapter, and it will see that, okay, my signals delay is this much, and according to this and according to some calculations that I performed on this delay, this person might be standing at this point in my coverage area, and it tells you nothing else. So now this information has to be translated into longitude and latitude somehow. How would that be done? That would be probably done that the application that will get this information will move it to another higher level, that will say, okay, at this point means that this person is standing at this point in the building, and then this building is situated at this point in the map, and the approximate latitude and longitude would be this one. So this is in opposition to simple getting a latitude and longitude in the first place. We are going through multiple steps to get this simple information. So this is again how dynamic your context sources would be, and how different formats your application, your information would be available in. Now consider that you have to write an application for such a device. You have to consider all the formats that your application would get. You will have to consider all these kind of different resources that will provide you with information, and then you will have to make it meaningful. This is again a very time-taking and has to be well thought of, and this adds up to the complexity of writing a mobile or pervasive platform software. Getting data from multiple sources is always problematic. I mean, even if the source is same, the format difference creates a lot of problems. Think about it in desktop environment. If you have the modern version of Office installed, say for example Office 2007, and you save your document in Office 2007, and then you take it somewhere else where Office 2003 is installed, Office would refuse to open that document, or it will start showing you junk. Why is that? Because Office 2000 save information in a different format than that of Office 2003. The company is same, the product is same, only the difference is only some versioning, and you wouldn't be able to open your document itself. Here in pervasive environment, we are talking about different sources altogether who may not be actually designed to do these kind of services. Their only purpose is to disseminate information. Consider satellite. The GPS assisting satellites are only there to give you longitude and latitude. They are not bothered how would you use this application or this information. They will just give you some simple numbers and rest is up to your application. The weather services, they will be providing you a lot of data. I mean, you will curate and it will provide you with data. They are not concerned with that you are sitting in Pakistan and you are asking about the information of London, the capital of England, or today is Monday, for example, and you are asking about the weather on Friday. They are not bothered. You query it and they will return you some data. How you will make use of it is your application's headache. The information is provided to you in different format, however they may feel fit. Because flight information, say for example, if you query it, it's probably a very well fitted that it tells you a binary number, that you query it saying whether there would be a flight scheduled at gate 15 and it would say yes or no. You can even restrict it with a time duration, saying that is there a flight scheduled at gate 15 for next 1 hour, and it will again give you a binary number. But for weather, you can't do that. Why? Because then it would be very difficult to make this series of queries. You probably would be saying, would Friday temperature would be 21 centigrade? Yes or no? It will give you some answer. Okay, then you will say, okay, would it be 22? Would it be 23? Would it 24? Or you will start doing the ranges. It would be much more easier that you will query it saying what would be the temperature, and it will give you the temperature back. But in some other scenario where you are only concerned with whether weather is good enough to permit a flight or not, you will just say, is weather clear? Are flights permitted? And you will get an answer yes or no. So the application and the data sources can be variety that can take any form based on what purpose they are going to serve. If the airport services are only designed to serve this information that weather is clear and all flights are permitted, or weather is not clear and all flights are not permitted, then it's a binary value. And whenever you query them, you will get one value that is sufficient for you for decision. But in other case, it's simple weather services. It will tell you this is the weather, and your application has to decide whether this weather is good enough for a flight to land. Or in more complex application, you might have to send this information to another source, asking them that, okay, this is the weather information I got, whether this weather is good enough to get a flight landed, and it will return you a response saying yes or no. So these are the few examples of how different data sources can be, how different the context sources can be, and how differently your application will play with them. It wouldn't be same, it wouldn't be uniform, and that makes developing a software in context-aware environment more difficult. Then, how would we tackle it? We have seen all these things. We have seen that user interaction is a problem. We see interaction modalities has a problem. Because why is that? Because we have to write the view component altogether for every device. We have to write the controller component altogether for every device. Connectivity is unreliable, so we have to take care of disconnected operations. In some cases, I said that we can use caches, but caches has a limited use because we have limited memory available. In some cases, we might be able to allocate 1 MB of our main memory to the application itself. But in other cases, we might have only few KBs available and we might not be able to spare anything away for the application. How would caching work in that environment? or maybe caching won't work altogether. These are things that makes the pervasive environment heterogeneous. And you might be able to start understanding the concept that when we say developing software for pervasive environment is difficult. So how would we tackle this problem? What can we do to make it uniform? Of course, we can't change the devices. And if you remember, last time when we discussed, we were saying that in 2011 we might be touching 160 million pieces, and maybe in 160 million pieces we have to rewrite our devices maybe for a few thousands of them. Still a very big number. What we can do to address this problem, to address the heterogeneity of device platform, what we can do to address the heterogeneity of the context sources, how we can cater for different formats. Because let's face it, if an application has to do everything from collecting data, that is binding to different data sources, and then combine them together, all the information coming to it from different sources is in different formats. There is different type of devices that are providing you with this information, and in some cases you can't connect to the network alone. So what can we do to address this problem? And the answer is make these components, make these things platform independent. That is, make your model, make your view, make your controller platform independent. And how would we do that? This we will continue discussing in the next lecture, and our focus in that lecture would be how would we make these things device independent, or how can we come close to the device independence so that the portability doesn't become much of a challenge. We will be in next lecture, we will be winding up our discussion on the mobile and pervasive computing software development by addressing this key concept, that is how can we port our software from one platform to another platform without overwriting it. I mean, you can obviously port one platform to another by rewriting the whole view component, say for example, or rewriting the whole model, or rewriting the whole controller thing, and that is also considered portability, but then it's not economic at all. If you are writing for few thousand devices alone, this will take huge time or manpower to do this porting. So how can we make these components platform independent so that we can easily port from one platform to another? This would be our discussion for the next lecture, and in next lecture we will also try to wind up the software development aspect of mobile and pervasive computing, that why it is different and why it is difficult to write software for such a platform. Till then, I am Abdul Aziz signing off. Have a good day.